some time to think about how you would complete these problems first and give it a try before you continue these problems. And for whenever you're ready, you can continue the video and we'll go over the solutions together. In part A, we have this f of x, and we want to start off by essentially factoring out the leading coefficient. So we get f of x is equal to, here the leading coefficient is 2, and if we factor this out, x squared plus 4x, and remember we're just leaving the constant term alone, we're not doing anything with it. And with the variable terms here, we want to think about what number do I need to include, or how do I write this as a perfect square form over here. And if I factor out the 2 and think about x squared plus 4x is what I have, I should have x plus 2 as a perfect square. And if you want to think about what's the additional term that we have included, that term always comes from the last times last, which is 2 times 2. And as we do this, which gives us 4, we want to subtract away the 4, because that 4 didn't exist in the previous step. And then carry down that minus 5. And especially if you're new to this process, definitely don't hesitate to write down what the perfect square would look like with your proposed perfect square. So here, if you know you wrote down x plus 2 squared, just take some time to think about x plus 2 times x plus 2. That becomes x squared plus 2x plus 2x plus 4. That's a FOIL process, and that's x squared plus 4x plus 4. So now compare this step to the previous step. If I want to write this as a perfect square, that means I had an additional term 4, so I need to subtract away. And just by writing this side note for yourself, it can be really helpful for you to keep track of what's the process that's going on over here. And once we have this form, we are mostly done, and we just want to clean this up with some algebra. By distributing the 2, we have 2 times x plus 2 squared minus 8 minus 5. So altogether, we get 2 times x plus 2 squared minus 13. And if you want to find the vertex from the vertex form, we get negative 2, negative 13. So always, whatever is the opposite of the second term in the perfect square, we want that to be negative 2, and then negative 13 over here, be in the y-coordinate. Now moving on to part B. We want to do the same thing. We have a negative leading coefficient, but that's perfectly fine. We can factor out negative 3, and that becomes x squared minus 8x. Again, notice a sign change when you factor out a negative factor. And here, if I have negative 3 factored out, and inside the bracket, if I have x squared minus 8x, that means it will be part of the perfect square trinomial of x minus 4 squared, because negative 8 divided by 2 gives us negative 4, which again comes from the fact that we have the same inside and outside terms. That just doubles. And now think about what term did you add in addition. We have that negative 4 times negative 4, which is the last times the last process. So we get 16. And that 16 didn't exist in the previous step, so I want to subtract away that 16. And then close the bracket and carry that plus 4 that was always there. To clean this up, we would have negative 3 times x minus 4 squared plus 48 plus 4. So we would get negative 3 x minus 4 squared plus 52. So the vertex form, or the vertex, if we want to find it, will be 4, 52. And if you think these are all good, you can continue moving on to part C and D. In part C, we are doing the same process as before. The leading coefficient is 3, so we're going to go ahead and factor that out. So h of x is equal to 3 times x squared minus 3x. Again, we just leave the minus 1 out. And here, once we get this, we can think about if I have x squared minus 3x, that's going to become part of the trinomial that's part of x minus 3 over 2 squared. And to think about what would be the additional term, we just multiply negative 3 halves by negative 3 halves, which is 9 halves. So we're going to subtract 9 halves. And then lastly, do the minus 1. Again, especially if you are less comfortable with fractions, make sure you write out what's x minus 3 halves times x minus 3 halves, and make sure you do have x squared minus 3x as the variable part, and you do have 9/4 as the constant part. That's going to be really helpful for you to make sure your process is all correct. And from here we get 3 times x minus 3 halves squared, and 3 times negative 9/4 will be negative 27 over 4. And lastly, minus 1. With this process, we can combine the constants, and 1 can be turned into 4 over 4. So just this process, we can go ahead and find negative 27 over 4 minus 4 over 4 is negative 31 over 4. And therefore our vertex would be 3 halves, negative 31 over 4. And lastly, we have part D, which again is this problem where we have a little bit more fractions to work with, but that's perfectly fine, because once we have this process down, it doesn't matter whether we have fractions or not. It's always the same strategy. Here we want to factor out the leading coefficient to negative 2. Once we do so, we would have x squared minus 7 over 2x. Again, make sure you change the sign when you factor out negative value. And once you have this form, we want to think about what part of a perfect square would x squared minus 7 over 2x be. The answer should be x minus 7/4 squared. And this, again, I'm going to show the work of how we can check x minus 7 over 4 squared is indeed what we want. If we have x minus 7 over 4 squared, this is equivalent to what I just wrote out for the multiplication. So now going through the FOIL process, first is x times x, which is x squared. Outside is x times negative 7/4, which is minus 7/4 x. And inside, again, minus 7/4 x. And last, we have negative 7/4 times negative 7/4, which becomes plus 49 over 16 over here. And when you combine them, you will get x squared minus 7 over 2x plus 49 over 16. And you can see the first variable terms are identical to what we had in the previous step in the parentheses, and the additional constant is 49 over 16. Because we didn't have it, we have to subtract it away. And then we want to do minus 2. And I'm going to kind of create a barrier between the side note and what we're doing here. And once we have this form, we want to think about simplifying this and get negative 2 times x minus 7 over 4 squared. Then we would have plus 49 over 8, because we have a cancellation of a factor of 2 on top and bottom, and then minus 2. So altogether we get this perfect squared plus 49 over 8 minus 16 over 8. That comes from 2 being 2 over 1 and multiply 8 on both sides. So now we can finally combine the constant terms and get 49 minus 16 is equal to 33 all over 8. And therefore, if you wanted to find the vertex from the vertex form, we would get 7/4 33 over 8 as a result.